Okay, guys and girls, so for the next 2 days we're going to be reviewing everything we learned from this unit about exponential and logarithmic functions. So what I'm going to do is I'm going to quickly go over a few different examples, and then you guys are going to just practice by completing some problems from the Unit 7 test study guide. Remember, that's going to be in the back of your packet. So to start off, we have a few problems that look like this. We are just describing a function as an exponential decay or an exponential growth. All you have to do here is look at your b value, which, remember, that's the base. That's the thing that is being raised to a variable exponent. If it is less than 1, like 2/3 is, then you're going to go ahead and have a decay. If it's greater than 1, you're going to have a growth. So number 2 should be pretty easy after that. And then we're going to go ahead and graph exponential functions. So I'm going to do number 3 for you here. And first thing I like to do is go ahead and graph it in my calculator. In this case, if you don't have a graphic calculator at home, use Desmos. And then I like to list out my shifts. This one looks like it's going to go left 1 unit. That was because the x plus 1, and also down 6 units. The nice thing about all exponentials is they all have the same domain. It's all real numbers. Our range is a different story. In this case, usually our range is y is greater than 0, but we went down 6 units. So we now have an asymptote at y equals -6. So that means all of our y values are going to be above that. So we're going to say y is greater than -6. If you go ahead and graph this guy in your graphing calculator, you'll notice it looks something like this right here. So as we go to the right, as x goes towards infinity, our y value is going up. So I'm going to put infinity for that as well. As we go to the left, as x approaches negative infinity, we're actually getting closer and closer to -6. And then finally, to figure out what our y-intercept is, all we have to do is take a look at our table. If you're using Desmos, you can actually just get your cursor and put it right on top of that y-axis there. And when you put that in, you should get something like -3. So it's 0, -3. Then you're all done. A few of the other things we did is we converted from one form to another. So with these guys, you're going to rewrite in logarithmic form. Like for number 7, I'm going to say log base 8 of 64 is equal to 2. I can also go in the opposite direction. I can take a logarithmic expression and rewrite it as an exponential. So this would be 3 to the 3rd power equals 27. And then we learned about evaluating logs. That was essentially just saying our base to what power gives us our answer. So 9 to the x power equals 81. So some of them we can do in our head. But if we can't do one in our head, we can use our calculator, or in this case, go to Google and type in calculator, by using our change of base formula. All that means is for ones like number 20, we can actually rewrite this as log of 95 divided by log of 7. And that's something we can just do with our calculator. Remember, our calculator doesn't have the ability to give us whatever base we want, but we can go ahead and just rewrite it like that. And then you put that in your calculator, and let me see what we get right there. I think you get something like 2.3402. And then to finish off for today, I want you to do all of our condensing and expanding. So that's all our log properties. I'll go over the 3 here. Remember, if we have multiplication inside a log, we can actually break it up with addition, and that works both ways, right? We can go either direction there. If we have division inside a log, we can break it up with subtraction. And if we have a power, we can actually pull that power out in front as our coefficient. So I want you to use those guys in order to solve 23 through 28. So what I want you guys to do is numbers 1 through 4. Now you're going to skip numbers 5 and 6. But then you're going to go 7 up to 28 for today's practice. Remember, my hours are from 11 to 1, so if you need any help, just feel free to contact me then. Have a good day.